Hey, future data scientists and sleepy engineers. Welcome back to our channel. So, in today's video, we are diving into Numpy, the superhero library that makes numbers fly. So, without any further ado, let's give your Python some superpowers. So, think it like this. If Python lists are basically like bicycles, NumPy arrays are sports cars. So you can do math operations, slicing, matrix stuff and more at lightning speed. So for learning more about NumPy operations, first let us see what is NumPy exactly. So NumPy is the abbreviation. Its abbreviation is like a numerical Python. It's a library for fast numerical computation. It is used in machine learning, data sciences, simulations, basically at all the cool stuff. So for using NumPy in your laptop, first we need to install it. So we can install NumPy using this code like pip install NumPy. So if you run this line in your Windows terminal, you will get NumPy in your laptop. So first, to do something on arrays, NumPy arrays, first let us create NumPy array. So here is how you can create your array. So a is equals to you are giving the array name, like a is equals to np dot array, and you are giving the elements. So here what is np? It's like we have used like first to use it we have installed it, but to use it we need to import this. So we basically we import it as like import numpy as np. You can use, instead of np you can use anything. So whatever you give here, it goes here. So a is equals to np dot array, and you give your array. That's it. You have created your numpy array, more powerful than a Python list. So let's see some Python operations. So you have for this we will create two numpy arrays. A is equals to np dot array and b. So these are two arrays. So we can simply perform operations like print a plus b, then you will get the output and print a into b. So when we run this code, you will get the output 579 for a plus b and 4 10 18 for the product. So math happens element wise, no loops, so no stress. Okay, then let us see array types and shapes. Like let us create a numpy array, like 2D array, like 1 comma 2 and 3 and 4. So we have created a 2D array. When we print a dot shape and a dot d type, we will get like output 2 comma 2 and in 64. So what did this shape and d type tell us? Shape tells us you the size, like the rows and the columns, and the d type tells what kind of the data lives inside here, inside the arrays. So now let us see common numpy functions. So we have here we can see different common numpy functions. np dot zeros, when you do this, like it will gives you the matrix, like 2 by 3 matrix of all zeros. When you do npy dot ones, it will give you the matrix with ones. When you give npy dot i3, it give you a identity matrix of third order. So when you do np dot arrange 0 comma 10 comma 2, it will give you a list like two multiples. It's like the starting value goes here, the ending value goes here, and of which multiple you want that goes here. And np dot linspace, it gives you 0 comma 1.5. So it is like the starting value, the ending value again, then the 5. So here we have 0, 0.25, 0.5, 0.75 and 1. It's like dividing the spaces into 5 parts. So when coming to the indexing and slicing, first let us understand this through a snippet. We have a 2D Numpy array. When we print a of 0, 1, so what we get is 20. So what happened here is 0 is the index of the array and 1 is the index of the element in that specific array. So that is how it is. Now let us see another print. It's like slicing. Print a comma 0. Here we will get 10 and 30. It's like in the whole array we will through this we will get the whole all the arrays, and in that we will get the first element. As we have used the 0 in the index, we will get the first elements of all the arrays. So that is why we got 10, 30. So then let us see some useful math that we can do using Numpy. Here we have Numpy array A. So when we print np dot sum of A, it will give the sum of the elements, some mean, where it will give the mean of the array, and std we will get the standard deviation, and np dot max gives us the maximum, the biggest element of all the elements present. So it's like one liner math, so a lot of time is saved. So that's it.